Thank you, Jane. And hello, everyone. Today, I'm going to talk about a very nice topic, and it's about streaming vector data with Oracle GoldenGate 23ai. So I'm going to do a quick overview of what is vector data and how can we embed in data. And the most interesting part is how can we use this with Oracle Golden Gate? And I'm going to present to you a demonstration with two scenarios where one of them I'm going to generate data, an external vector data, embedding it, and then insert into the Oracle database and replicate this to a Postgre database. So we're going to use an heterogeneous data replication. And in the second scenario, we're gonna do something different. We're gonna insert the data into the Postgre, normal data, and then through Golden Gate, we're gonna transform this data into so Golden Gate can vector data to a vector data. So this is what I'm gonna show to you today. Okay? But before I start, let me just present myself. My name is Gilson Martins. I'm from Brazil. I'm an Oracle Ace Pro. I talk a lot about Oracle Golden Gate. If you know me, you're gonna see that I have many posts about this amazing tool. Sometimes I talk about other things, reading Oracle technologies too. And yeah, I work on GDBR solutions. I am a CEO and also an OGG and a DBA. Okay. I think most of you guys are from ACE program, but if you are not, I really encourage you to be part of this amazing team of professionals. In the Oracle ACE program, you can have access into many professionals that is always sharing knowledge and information around the world. And we also can have some benefits. You can participate into the events. And Oracle ACE programs makes you always being challenging yourself. You makes you improve every year, makes you keep getting network with other professional and participate of the Oracle community in your country and also around the world. So if you are interested, I really encourage you to get this QR code here and check more details. And if you want, you can also talk with me later and I can explain to you more details about the program. Okay? All right, so let's start. I'm gonna start doing a quick overview of a relational database and vector database, just to recap some basic concepts. So what is an Oracle relational database? Basically, a relational database is where we store structured data into tables with rows and columns. We use SQL or SQL commands to get the data. We set up this in a strong schema definition data. And also, we can use this usually for transaction systems with an RP, CRM, finance, and so on. So the basic idea is we have a table and we do a query, SQL query, to get the information. This is the relational database. And here is another example, just to see. This is a table with lines and columns. And if you want to get the data, we use a SQL query. And there is a very important thing here. When we use SQL commands to relational database, we are always looking for data exactly in the way we are asking for. So in this example, we are asking the data where category it's the same as replication. So we are looking always the data in the same form that we are looking it. Okay. This is basic architecture of relational database. And in this case, if we issue this query, we're going to retrieve the lines 1, 2, and 5 because these lines have the category with the information replication. Okay, all right, so far so good. Let's check how this happens in vector database and compare. So Vector database store vectors that representing the data uh, in a in a number information that I will show soon. And what else can we do? We use semantic search and AI applications to get this data. We can find similar items. We are not looking for the same word or the same phrase that we are looking. We find related data, not exactly the data that we are looking for as we do in relational database. And we use this vector database for chatbots, for recommendation engines, for RAG, for machine learning, and many other applications. And this we have here a quick example that is showing this. Let's say that we have an embedding phrase that it say how to replicate data in real time. And this information, we can retrieve it using a vector with a similar uh, with a similarity into the database to retrieve this data. Okay? And how this works, Gilson? Let me explain here. So here is an information. We have here a table with lines and columns, but this third column have the vector data, the embedding data that uh, we created. And when we are looking for information using vector search, we are looking for positions of these vectors and check if they are similar or not. And in this case, for instance, we can do a query like this one here, and we use this. Here is in Oracle, is one example. There are many other options to do this, but this is an example. And we use the vector embedding to looking for some phrase that it's similar to how to sync data. And the search happens and you retrieve us the phrase that it's similar to the one that we are asking for. So this is a big difference. In a relational database, we look exactly the information that we need. In vector database, we do a search with similar data, with data that have some similarity, not exactly the same information. Okay? So to finish here, the key difference is relational, we have structure and the data much match. And vector database, we use semantic, we use a phrase with a context, and we do similarity-based search. Okay? So just summarizing this issue, and why should you use Gilson vector data? There are many solutions, many embedding models that we can use it. For instance, let's say that we have a couple of images and we want to insert this image as a vector data into a database. What we should do? We need to use an embedding model that is specific for image, which this model will capture this image, will convert it into a vector data and insert this into the database. And we also can do this for text, for audio, and there are some others embedding models that we can use. So each vector that we have, we it was generated with a specific embedding models. Okay, and we have some embedding models that we are using the market right now. Okay, okay, and one thing more in this example, for instance, why we are using here for image, we can use these embedding models for image to check some object recognition, to deduplication information in the image, to scene detection, a face detection, for instance, and to looking for some specific object inside an image. And how can we use for any LP? We can use for translation, for understanding, for some sentimental things, for questions and answer, and semantic search. And the last one, the audio transformer. This is another embedding model we can use for speech to text, music transcription, machinery malfunction, some noise that makes the AI understand that this is an issue that it's happening, and so on. So, I want you to got here in this slide. We have many unstructured data, image, text, audio, and to convert this data, this unstructured data, into a vector data, we need to use an embedding model. And with this embedding model, we will have this vector data and we're going to insert it into the database. Okay? So, uh, how can vector embedding works? I created here three steps that can show us how this happened. And the first step is the tokenization, how tokenization works. So every word in a phrase that we create, it's separated and it's considered as a token. But depending of the embedding model that you are using, some tokens can be words, some tokens can be a character, some tokens can be some words. But the main idea is we input phrase, we input an information. This is a text example, and this model will tokenize in this, breaking this in small pieces and generating a vector to this information. And here is the step two. Let me show you how this happens. So in this case, we have a phrase, how to replicate data in real time. So in first step, we broke this phrase in small pieces like words. So how it's one token, two is another, replicate is another, and so on. In step two, I got these tokens and generated a vector data related to each of these words. And then comes the step number three. So we're gonna use some semantic. We're gonna transform this information into some meaning. We will give some meaning for uh, this group of vectors. And in this case, we're gonna generate one single vector which represents the meaning of the full sentence. Então, in this case, we are gonna convert this phrase into a single vector at the end of the process. Okay, so step one, broke into small pieces, it's tokenizing. Step two, we got this tokenized and generated an individual vector data. And then in the third step, we do the transformation where we got these small pieces and give a context, give an understanding of this meaning of this word and generate a single vector embedding. Okay? So this is a basic idea. And why you are generating, Gilson, all of these vectors? It's because the way we store data, it's not like rows and columns as we saw before. The way that we store data and give a meaning of this data, it's to position this data as a vector, uh, as a vector. And in this image, I can show you another example where I have different data that it's representing as vector, and we can find this related information just with the position of this vector in 2D example, like this one here. So for instance, let's say that we are looking for persons. Then we have the information about king, about man, about woman. These are informations that it's related. So the information is closer to each other. The next ones, the apple, banana, and orange. So it's fruits. So this information, the vector that generated uh, this data, it's also near to each other. And the last one, football, golf, and tennis, it's another kind of data that it's also related. And we can find this information using embedding models to looking for this information. So here comes next part that is similarity metrics. In this case, we use math calculations to determine if this data is similar or not. Remember when I said that relational database, we are looking for data that we are asking exactly what we are looking for. We are looking specific information in relational database. But when we are using vector database, we're not looking for specific words, specific information. We're looking for information that it's related. So we have the vectors that was created, and to find and retrieve this information, check if they are related or not, we use some calculations, some math calculations to retrieve this information and check which data is similar to another one. Okay, so we have some functions to do this. I will not go deeper on it. I just show that we have this is the most used. It's Euclidean distance and cosine similarity and dot product. And with this, we can use this method and define if these data are related or not. Okay. In Oracle, we have more details about that. We have this AI vector search user guide with many details and many demonstrations on how to use this. Okay. So why Oracle Golden Gate? I'm explaining all of this, but why Golden Gate have relation with these topics? I'm gonna show you right now. With Oracle Golden Gate, we can create many solutions, many replication solutions with data vector. We can also create, for instance, a vector hub. We can centralize all the vector data that we have in our company into a single database. And we can also integrate and replicate vector data across many databases and many platforms. So in this image, summarize all of this that I'm telling to you. So we can capture data as normal data. We also can capture embedding vector data, and we can replicate for another environments. And we also, through Golden Gate, are able to collect normal data, relational data, convert it into vector data, and send and apply this data to another database. And this is what I'm going to show you in these demonstrations here. Okay, so far so good. I don't know if questions it's allowed now or at the end, but if you have any questions,
They can put them in the chat if they want.
the chat.
Mhm.
Okay. Okay, good. Thanks, Jen. So if you have any questions, you can put on chat. And now I'm going to show you a demonstration of all of this that I'm telling to you. And this is the environment that we're going to work. Just let me see how much time I have. Okay, I have more some minutes. Okay, the environment that I prepared to show off this step is this one. So we have here on-premise environment with an Oracle database and a Postgre database, and also two Golden Gate deployments, one for capture data from Oracle and other to deliver and capture data from Postgre. And also we have a third database that is an OCI, it's on cloud, okay? And in this first replication step, what we're gonna do, we're gonna get some data from an API, an external API. So let's say that we have an application that we are already using vector data. We are already working with NI, and I want to integrate it with Oracle and a Postgre database. How can we do this? So we are gonna get this information with a Python API. We're gonna transform this information in a vector data, and after that, we are going to insert this data into an Oracle database. And after that, our Golden Gate is going to capture this data from Oracle, send it to the Golden Gate for non-Oracle, and apply this on the Postgre environment. Oops, sorry. I passed. Okay. Go back, please. Hey. And because this is the example that I'm going to show you in this first example. Okay, so are you ready? Let's go. So here, what we have, I I have here all the environments already open. So we have here database from source, which I'm gonna connect it. It's an Oracle database, 23ai, and it must be 23ai because it's the one that's support vector data. Okay. We also have here another server with a Postgre installed. I'm gonna connect it right now. Okay. And if you check, oops, this is the databases that we are using here. We are using this one, the GDBR Golden Labs, and also we have two GoldenGate deployments. We have an OGG for Oracle. I'm gonna connect it right now. And the OGG for Oracle, which is gonna capture and apply data into Oracle databases. We have here two processes, one extract and one replicates. For this example, we are using this extract, this trail, and these replicates. Okay, so in the search in the Oracle, we have this one that is the eGDBR01, and in a Golden Gate for Postgre, let's check here. I'm gonna connect it, and we are gonna check the replicate here. So this is the duplicates that we have. So now let's start. I just prepare here the step that we're gonna execute. So first of all, let's check the table that we are gonna replicate into Oracle. So this is the table, have these four columns, ID, title, content, and embedding. If we select count here, we're gonna see that it's empty. Okay. And in the Postgre, if we check the same table, it's also empty. Okay. Whoops. What I did wrong here. Sorry. Okay. It just spaced it. Okay. So it's 0 rows. So we have no data into both database. And what we're gonna do now, we're gonna execute our API, this API, which we have some information that is gonna be converted into the vector data and it will be inserted into the Oracle database. So let's do this.
And I have one
And
question.
this,
Sorry.
sure.
Since the demo architecture shows Golden Gate on premises, but it is
Mhm,
true if we use OCI Golden Gate Cloud Service. Um,
this here.
is that, yeah, is that
Yeah, we can use cloud or Golden Gate from cloud, but in this specific demonstration, we are using Golden Gate on premises. So it's a full installed version.
okay? But you can use OCI Golden Gate Cloud Service. Okay, I think that's what the person's asking. And we just have
Yes.
one more minute. So
Well,
if you just want to, yeah.
okay. Just 1 more minute. Okay, just let me just run this script here to generate the data. I think I won't be able to explain the first replication, just to show you replication. And this time, the API from Python just get the information that I saved it here, converted each into vector, and inserted each into our Oracle database. And if we go back into the Oracle and check the data, we're gonna see that we have 20 records here. We can also do this query here to check the data is inside and also it's embedding. Check here. We have the data as text and the data as embedding. And if we go into the Postgre, we're gonna check that the data is already inserted there and it's embedded too. I have another query here that shows better than this. This here. This is the last command. Okay, and we can see that in the Postgre we have the data here, and also the embedding vector was replicated through the Golden Gate. Okay, so the other example is pretty cool too, but I don't have time. And we are gonna insert the data into the Postgre, and this data is going to be converted through the Golden Gate and generated this vector data with the Golden Gate replicate process. Okay, so that's it.